In a previous video called Swinging Around the Circle, I taught you 5 ways to handle a situation like this, or like this, or like this. Now, what they have in common is that they fit a certain template. Basically, it's sine of something equals something, or it's cos of something equals something, or it's tan of something equals something. Okay, now this is just my silly little terms. I call this the peanut template. I give it a silly name just to emphasize the fact that you can't do anything. You can't reach for the calculator and go shift sign. You can't use your knowledge of the 3x3 table. You can't swing around the circle unless what you're staring at literally fits. Sine of a Christmas tree equals a peanut, or cos of the computer mouse equals the real mouse, or tan of the football equals the cricket ball. Now that's the case for all of these, which means you can reach for a calculator and go shift sign. Or you can swing around the circle and think, what does it take for my x-coordinate to be 1? Because the role of the Christmas tree is played by theta, the role of the peanut is played by 3/5. The role of the computer mouse is played by theta, the role of the real mouse is played by 1, the role of the football is played by theta, and the role of the cricket ball is played by negative 0.1. So that means that these are good to go. Okay, but even a slight change from this template wrecks it. So that is not ready. That is not good to go. It's premature to start thinking about shift sign or inverse trig on this. Okay, this is doesn't fit the template. We're not allowed to have trig on both sides. We need to have trig on one side, a simple angle, and then a number on the other side. And finally, this one here. Well, not finally, actually, I'll do 2 more examples. That one is pretty far removed from this template. And let's do one other one. Let's say 2 sine squared theta plus 3 sine theta plus 1 equals 0. Okay, now, to take these equations and make them fit this template, you've got to use all the tricks of the trade. Now, the simplest one is this. You just divide both sides by 2 and you're good to go. And that's one which your general knowledge should tell you that the basic angle that makes that true, the basic angle that you then tuck against the x-axis, is 30. This one, a red dude of dividing both sides by cos theta, will produce sine theta over cos theta equals 1. And your knowledge of identities tells you that there's a simpler name for that expression, and that simpler name is tan theta. So that's now good to go, because the role of the football is played by theta and the role of the cricket ball is played by 1. This one, same thing again. You get to use both your famous identities for that. The left hand side is tan theta and the right hand side is just 1. So in fact that is the same as equation. That is the same equation as that one. And this one, you've got to use your algebra skills. Okay, now I'm always terrified that my algebra skills are going to fail me in a trigonometric context. So I'm a massive fan of making little substitutions like this. And then it's just psychologically more likely that I'll be able to do my algebra properly. So if u equals sine theta, then this is what we get. You then factorize that. And then the answers pop straight out. And then you can put the trigonometry back in. So you now get 2 sources of solutions. Both these fit the template. They both look like this. So your basic angle is, for this is 30. So you tuck a 30 against the x-axis, and then you're good to go. How do you get a sine to be -1? Well, you've got to be way down at the bottom of the circle there. So your basic answer for that is -90, 270. You've got to consult your domain in order to work out which of those is the case. So basically, the message of this video is, for goodness sake, do not fall into the trap of doing trigonometry earlier than you're supposed to. You cannot do trigonometry. You cannot reach for the calculator and go shift sign unless you've got something that looks like this. And your job is to bust your gut using algebra skills, whether it's this or trigonometric identities. So for example, this becoming this and this becoming this, until by hook or by crook what you have does look like this. And then you can work out what theta must be.